Hello, Math 95 students. This is section 13.5, which is about solving radical equations. All right, the other sections have been about how to simplify radical expressions, but this section is how to solve a radical equation, meaning it's got an equal to sign involved, and the goal is to get the variable by itself. So we're going to use our algebra skills to get the variable by itself. The extra skill that you're going to learn in this section, that to add to your previous skills that you've learned earlier in your mathematical career, is how to get rid of a radical. You get rid of a radical by using an exponent. All right? To get rid of a radical, by using an exponent. And the exponent that matches the index of the radical. So just like adding and subtracting are inverse operations that cancel each other out, multiplying and dividing cancel each other out, exponents and radicals are inverse operations that cancel each other out. All right, so we are going to apply that to this first problem here. All right, we have this radical, and what is the index of that radical? It's understood to be a square root. It's understood to be an index of 2, right? There's an invisible 2. There's an invisible 2 right there. That's understood. Anytime you have a radical that doesn't have an index, it's understood to be an invisible 2. So the way that I will get rid of that index of 2 is by using an exponent of 2. Square root of 6x minus 2, I'm going to square it. And whatever I do to one side of the equation, I do to the other side of the equation. So that 2 exponent kills that 2 radical. And what do I have? I now have 6x minus 2 equals 4 squared is 16. And now you know how to do this from here. You've done the rest of these steps many times before in your mathematical life. So you're just going to get rid of the minus 2 by adding 2. That gives me 6x equals 18. I'm going to get rid of the 6 by dividing by 6. And that gives me x equals 3 as my answer. A little bit of bad news is that sometimes when you're doing these, kind of like on the previous chapter on the radical equations, sometimes we got answers that were extraneous solutions. It means that we got the solution, but when we plug it back into the original problem, it doesn't actually work. That can also happen sometimes on radicals, because sometimes when you plug it back in, you might get a negative number under the radical, and if you get a negative number under the radical, that becomes an imaginary number, and so it doesn't actually equal the real number that it's supposed to equal on the other side. So we have to check it. So just plug the 3 back in. The square root of 6 times 3 minus 2, that's 18 minus 2. That's the square root of 16 equals 4. So 4 equals 4 is true. We're good to go. That is the answer. All right, why don't you go ahead and use the same thing we did, the same skills we did on the previous one for this one. Okay, how do we get rid of that square root? By using a squared exponent. We square both sides, and that squared exponent gets rid of that square root. And so now we have x plus 5 equals, what's negative 3 squared? Positive 9. And then subtract 5 from both sides, and x equals 4. Now, check it though. Square root of square root of 4 plus 5 equals negative 3. That's the square root of 9 equals negative 3. But the square root of 9, the principal square root of 9 is understood to be 3, not negative 3. So that actually does not work. So 4 is not a true solution. So that means we don't have a solution, because 4 was the only possibility, and it doesn't work, so there's no solution. All right, let's look at this one. Okay, what we want to do is we want to go in the proper order. That means we're going to get rid of that plus 5 first. We're going to subtract 5 from both sides. And that gives us 2 square root x equals 8. Then divide both sides by 2. That's what I'll get rid of next. What is going on? Come on now. So now the square root of x equals 8 divided by 2 is 4. Now I can get rid of the radical. How do I get rid of that square root? By squaring it. Square both sides to get rid of that square root. And so what does that give me? That gives me x equals 16 as my answer. And then just go back and check it. 2 square root 16 plus 5 equals 13. So that's going to be 2 times 4 plus 5. That's going to be 8 plus 5 equals 13. And that's true. So 16 is a good answer. This example may be slightly more difficult, but not too much, I don't think. Here we have a radical on this side of the equation where we have just an x on this side. When that's the case, get the radical by itself. All right, isolate the radical. Get the radical by itself first before you get rid of the radical. And so we're going to move the 3 over by subtracting 3 from both sides. And that's going to give me x minus 3 equals the square root of x minus 1. Then I'm going to get rid of the radical by squaring both sides. Again, to get rid of the square root, use a squared exponent. So that cancels that radical out. But over here on the left was what makes this a little more difficult, is I got to do x minus 3 squared. That means I have to do x minus 3 times itself. So that's distributing. That's going to be x squared minus 3x plus 9. So that's going to be x squared minus 6x plus 9 equals x minus 1. And so then probably what I want to do is move all the terms to the same side, get everything on the same side, combine all my like terms, and then see what I can do from there to solve. So I'm going to move my x by subtracting x from both sides. I'm going to move my minus 1 by adding 1 to both sides. And that's going to give me x squared minus 7x plus 10 equals 0. And then if I can factor, I would like to see if I can factor. And if I can, then I will. If I can't factor, then I will have to do the quadratic formula. But I believe I can factor this. I'm kind of out of room here. So I'm going to factor it over here. That's going to factor as x minus 5, x minus 2. Right? Negative 5 times negative 2 is 10. Negative 5 plus negative 2 is negative 7. And then I solve both of these by setting both of them equal to 0, and I will get positive 5 and positive 2 when I solve them. And so those are my answers, but I got to check them. So let me check those answers. All right, 5 equals the square root of 5 minus 1 plus 3. So 5 equals the square root of 4 plus 3. So 5 equals 2 plus 3, and that is true. So I believe the 5 works. Now let me try the 2. 2 equals the square root of 2 minus 1 plus 3. 2 equals the square root of 1 plus 3. 2 equals 1 plus 3. 2 equals 4. Doesn't work. So the 5 works, but the 2 does not work. So really the answer is just x equals 5 on that problem. All right, this problem says find the x-intercepts of the graph of f of x equals the square root of 3x minus 4 minus the square root of x plus 2. That just means I plug in 0 for f of x or for y. To find the x-intercepts, you're always going to plug in 0 for y or f of x. So it's just going to be 0 equals the square root of 3x minus 4 minus the square root of x plus 2. And then I'm just going to move one of these radicals to the other side. It doesn't matter which one. I guess I'll just move this one. Well, no, I think I want to move the other one. Yeah, let me move this one by adding it. That way it'll be positive. Be a little simpler. So that gives me the square root of x plus 2 equals the square root of 3x minus 4. And then I can get rid of both square roots in one single step by simply squaring both sides. That will cancel out both of these square roots. And so I just get x plus 2 equals 3x minus 4. I'm going to get my x's together. You can move either one of them. I'm going to move my x. That gives me 2 equals 2x minus 4. Add 4 to both sides. That gives me 6 equals 2x divided by 2. And x equals 3. But I need to check it. So let me try. 0 equals the square root of 3 times 3 minus 4 minus the square root of 3 plus 2. Okay, so 0 equals the square root of 9 minus 4 minus the square root of 5. So 0 equals the square root of 5 minus the square root of 5. And that does equal 0, so I think it does work. So 3 is a good answer there. And finally here on this example, we get to an example with something besides just a square root. It's a cube root. So how do we do that? Well, we do it pretty much the same way. I don't think you're going to find this to be any harder than anything we've been doing. So you get rid of that plus 7 first by subtracting 7 from both sides. That gives me the cube root of 2w minus 4 equals 9 minus 7 is 2. Then we have to get rid of the cube root. How do you think we're going to get rid of a cube root? By using a cubed exponent. A cubed exponent will cancel out a cube root. So that gives me 2w minus 4 equals 2 cubed is 8, because 2 times 2 times 2 is 8. And then just keep on solving it with your good old algebra skills. 2w equals 12. W equals 6. And then you might want to check it. The cube root of 2 times 6 minus 4. Usually with odd numbered roots, you're not going to have any problems. It'll always check fine with odd numbered indexes, but let's just check it anyway. 12 minus 4 plus 7. So the cube root of 8 plus 7. So 2 plus 7. So that works. All right, and that is good enough for all the examples of this section. And that ends us up for chapter 13. So good luck on that assignment on 13.5. And maybe I'll see you again in another video.